Here we have another test. It is called root test. Okay, let's look over what it says. It says if we have a given infinite series, suppose the limit n approaches to infinity of an in absolute value power 1 by n. If that limit is L, if L is less than 1, then series converges absolutely. Remember, absolutely means that absolute value of the series converges, and that also implies the series itself converges because absolute value is a strong condition. Okay, if L is more than 1, including L infinity, the series diverges. If L is equal to 1, then test is inconclusive. That means you have to use some other strategy. So let's try this on this question. Determine if this series converges or diverges. In this case, an is equal to n squared by 2 the power n. We need to find limit n approaches to infinity of an power 1 by n. Let's see what that is. Limit n approaches to infinity of an is n squared by 2 the power n power 1 by n. So that means 1 by n of everything inside, and everything is positive. So we can remove absolute value because everything is already positive. It doesn't changes anything inside. So we have n the power 1 by n power 2 and 2 the power n the power 1 by n. That will just be 2. N and 1 by n will cancel. Now, there is an important limit we learn in calculus. It says limit x approaches to infinity, x the power 1 by x is equal to 1. Okay, please remember that. This is used a lot in this ratio test. So limit n approaches to infinity, n the power 1 by n will approach to 1 using that by 2, which is 1 by 2. We found the limit. Now we check, is this limit less than 1, more than 1, or equal to 1? Clearly this one is less than 1. So we have our first case, this series n1 to infinity n squared by 2n converges absolutely using root test. Let's do another example of the root test. We have the series given. En here is negative 2n by n plus 1 power 5n. For the root test, we need to take limit n approaches to infinity, absolute value of negative 2n by n plus 1 power 5n whole the power 1 by n, because of we need to take that root test. Now the negative sign will be taken care by absolute value. And what happens to power? Powers of power multiplies. So what do we have? 2n by n plus 1 power 5n times 1 by n is 5 basically. Okay. Limit n approaches to infinity to the power 5, and the remaining thing I'm going to just write it like this. How are we going to find this limit? The highest power of n in the denominator is n, so I'm going to 1 divide everywhere by n. Limit n approaches to infinity to the power 5 is 32. 1 by 1 plus 1 by n power 5. We know that this thing is approaching to 0 as n approaches to infinity. Therefore, what do we have? 32 times 1 the power 5. That is 32. So we found the limit of nth root right here, and this is clearly more than 1. So which case is it? Second case. If L is more than 1, we claim that the given series diverges.